Okay, so this is going to be a series of videos then talking you through some unstructured calculations questions, which will be more like the sort of things you might find in your second year exams. Okay, so the calculations here are designed to be a bit more challenging, or they get more challenging as we go through this worksheet, and it's looking at some of the more of the unstructured methods that you have to go through. So you have to put all the steps in yourself, rather than being guided through the exam question, through the calculation, like you might see on some of the older specification calculations in particular. So let's start with this one. A 0.11 gram sample of pure barium was added to 100 centimetre cubed of water. What is the concentration of the barium hydroxide solution that is formed? You can see there that we've got the equation. Yeah, that camera's focused. We've got the equation here, Ba plus 2H2O gives barium hydroxide and hydrogen. So the ratio of barium to barium hydroxide is 1 to 1. Therefore, the number of moles of barium here will be equal to the number of moles of barium hydroxide we form here. So if we can work out the number of moles of barium we've got from the mass, which we can, right, we are then going to dissolve that in this quantity of water, forming that same quantity of barium hydroxide. So students can sometimes get themselves tied in knots with this one because they don't realise the volume of water you're using is the same as the volume of your solution. Okay, you've got this much water, therefore you're going to make this amount of aqueous solution. So I have a mass of barium, I can work out a number of moles of barium. The moles of barium will be equal to the moles of barium hydroxide, and then it's just a simple concentration calculation. So let's start there. Number of moles of barium is equal to the mass over the molar mass. My mass is 0.11 grams. We don't need the G in the calculation, let's take that back out. The molar mass, check out your periodic table for the molar mass of barium and you'll see it's 137.3. So work that out first of all, and you should get an answer of 0.0008012. Okay, or use standard form if you're more comfortable with that. So that's my moles of barium. Therefore, that's the same number of moles of barium hydroxide that I can make in this situation here. So what's going to happen now then? I can work out, if I state this is also equal to the moles of barium hydroxide. So the concentration of barium hydroxide is going to be equal to the number of moles times by 1,000 over volume. Okay, these are the calculations, the molar calculations, which you need to be able to remember. So I plug my numbers into that formula. Number of moles, you can see above, 0.0008012, times that by 1,000, divided by the volume, which is going to be 100 centimetres cubed, because that's how much of the solution I've got. Okay, you can cancel down if you want to, or put the numbers directly into your calculator, and you should get a final answer here of 0.00801 moles per decimeters cubed. There we go. Nice and straightforward for that first one there, but its simplicity can also be its downfall if you fail to spot what the volume of the water is the same as the volume of the solution you're making.